Okay, so today we are going to be talking about linear, quadratic, and exponential models. And when we're doing this, please feel free to stop and pause the video so that you can write down the notes. So in this type of problem, we're going to decide, let's say we wanted to graph these points, and we would go -2 on the x and 9 on the y, and then -1 and 16, and then 0 and 25. If we wanted to graph all these points, what kind of shape would the graph take? And if it's linear, the graph will take a straight line shape, either increasing or decreasing. If it's quadratic, you're going to have a parabola, either opening up or opening down. And if it's exponential, then the graph is going to grow exponentially. Oops, lost our feed. So in the exponential graph, it's going to grow up like that, or decrease rather rapidly and then level off. So when you want to do this to decide, you could graph the points like I said, but then you're going to be getting really high in your y values. 49 is pretty high. Another option is to take the differences, and what you can do is take the differences between consecutive y values, meaning these two, and then these two, and these two, and these two. So if you were going to subtract 16 minus 9, y2 minus y1, you'd get 7. And then if we were going to go 25 minus 16, that gives me 9. And then if you go 36 minus 25, well, 36 minus 25, that's 11. And then 49 minus 36, that is 13. Now, that's the first differences, and as you can see, now we've got these first differences, 7, 9, 11, 13, but you don't see any commonalities here. So let's try and take the second differences. When we take the second differences, we basically do the same thing. 9 minus 7, y2 minus y1. 9 minus 7 is 2. When we go 11 minus 9, 11 minus 9 is also 2. 13 minus 11, also 2. And as you can see, we get these second differences to be the same. And when the second differences are the same, like this is a quadratic function. Meaning that the graph is going to look like this right here, like a parabola. Okay? So let's look at another table of values and see if we can't find one that's either linear or exponential. Here's a table of values. And in this table of values, let's start by taking the differences. So when in this difference, we're going to go 3.5 minus 2. Well, that gives me 1.5. 5 minus 3.5, again, 1.5. 6.5 minus 5, again, 1.5. 8 minus 6.5, that gives me 1.5. As you can see in this case, the first differences, the ones that we took off right off the bat first, are the same. And in this case, we call that linear, meaning that the graph is going to create a straight line. Something like this, if you were to graph all those points. Finally, we've got this option. Let's look at the differences in this table right here. Now, as you can guess, we've already gone through quadratic and linear, and so probably this option is going to be exponential, but let's see what happens. So if we were going to go 0.5 minus 0.25, when I subtract that, I get 0.25. When I subtract 1 minus 0.5, that gives me 0.5. When I subtract 2 minus 1, that gives me 1. And when I subtract 4 minus 2, that gives me 2. Obviously, the first differences are not the same, so it's not linear. So let's try the second differences. Here, 0.5 minus 0.25. That gives me 0.25. Let's try 1 minus 0.5. Again, 0.5. 2 minus 1. Well, that's 2. So as you can see, our patterns kind of start to repeat. We get the 0.25, 0.5, 1, 0.25, 0.5, oops, here, 1. In this case, when that happens, no relationship. In differences, then that's exponential. And in this case, the graph is going to start rising very slowly and then increase rapidly. So the graph will look like that. Now, the other place that we can decide whether we've got linear, quadratic, or exponential is in story problems. And again, I would pause this video so that you can write down the notes. I apologize that it's kind of long today. A man is shot out of a cannon. He flies through the air and lands on a soft mat. What type of function would you expect to use? Well, if the man is shot out of the cannon, if this is the cannon, and then there's like wheels on it. I don't know. So there's a man flying out of a cannon, right? He's going to go up and land on a soft mat. What type of function would this be? Well, it's a curve. It looks like an upside-down parabola, so we would call this quadratic. Okay, the next option. You sell cookies for $4 per box. You invest $10 to make the cookies. You want to know how many boxes you will have to sell before you start making a profit. Okay, well, in this case, the increase is steady, $4 per box. And even though you invest $10, you're going to start moving up by $4 every single time. And there's a constant increase. When you have a constant increase, this is a linear function. Because you sell $4 and then $4 more, and then $4 more, and then $4 more. The line starts to increase like that. You earn an allowance that's 1 cent on the first day, and 2 cents on the second day, and 4 cents on the third day, etc. What type of function would you use to model this situation? Well, in this case, it's doubling. Every time your allowance is doubling. However you spell doubling. Since it's doubling, this is going to be an exponential model. Okay, because it's going to increase slowly at first and then rapidly as you go along. So please feel free to watch this video again if you need to, and pause it and take notes. Thank you.